Welcome. This is Jessica Gulick, CEO of Cat's Eye, a strategy and marketing consulting firm specializing on tech firms. Welcome to today's series, Tech and Cybersecurity Trends. Today, we're really focused on the science and practical applications of unstructured content analytics. We have with us two special folks here, our speakers today. We have Peter Fitzsimmons, CEO of Contexture, and Greg Lovell, CTO of Contexture. Thank you guys for joining me today.
Thanks, Jessica. It's great to be here.
Thanks, Jessica.
We're really looking forward to really exploring what you guys mean by natural language and how it can be applied to our business problems. Why don't we go ahead and get started today? Do you mind introducing yourselves and your company real quick?
Sure. I'm Pete Fitzsimmons. I'm the CEO of Contexture. We're a natural language processing and machine learning technology company located in Reston, Virginia. And with me here today is our CTO, Craig Lovell. Craig?
Hi, everyone. My name is Craig Lovell. I'm the CTO at Contexture. And Pete and I co-founded Contexture to build natural language processing applications in the content space. So the first part of this talk, let me get started here. We're going to start off by just taking a survey of the history of NLP, looking at some of its milestones through history. And I'll open up with an overview of the NLP technology space. So we'll look at all the different techniques and tools that are classified as natural language processing technologies. And then the second part of the talk, I'll hand it over to Pete for him to talk about actual business applications of natural language processing. And we'll end up with some questions. So the first thing to get out of the way is, what is natural language processing? So NLP is the field of artificial intelligence that deals with programming computers to understand human language. So what we'd like for you to get out of this talk is our goals are to provide an overview of the field by looking through what I'll refer to as the Nlp Iceberg, which is a very layered wall of technologies that are composed together to create NLP applications. The second thing I want to convey is something of the breadth and the scope of the field of NLP. So there are lots of applications. We'll talk about them both in terms of technology and also the practical business applications of them. And I'd like everyone to come away with this with kind of an appreciation for how broad the field is and what are the current areas of research and areas of application development that are going on in the industry. And finally, we're going to discuss the real world applications and where this technology can be applied to today to give better user experience and to improve efficiency and to develop cutting edge applications in today's existing industries. So first, a quick whirlwind tour of natural language processing. The field of NLP was actually kicked off in 1950 by English cryptanalyst Alan Turing. He published a very famous paper in which he posited that computers could think. And in this paper, Turing actually thought that if we're going to be building computers that are intelligent and that can think, that we ought to have some objective test that tells us whether or not we've succeeded. So what does it mean for a computer program to be intelligent? And so the test that Turing came up with is actually a natural language processing problem. So in this paper, he said, if we can build a chatbot, and that chatbot has a conversation with a human, and a human judge looks at the transcript of the chat and can't tell which party is the human and which party is the computer, then we must have created something intelligent. So that was is known today as the Turing Test, and that was Turing's idea and for basically coming up with an objective criteria so that we can judge, have we created a computer program that's intelligent? So right off the bat, Turing has framed the problem of intelligence as actually an NLP problem. And shortly after that, applications started appearing and research was done in this area. So one of the earliest NLP applications was the Georgetown experiment, which was a program to translate between Russian and English a few sentences in the domain of organic chemistry. So this happened in 1954, and if you can believe it, this application was actually programmed and executed by feeding punch cards into an IBM mainframe. So we've come a long way since then. Soon after that, we started seeing an actual chatbot that popped up. So in 1967, Joseph Weizenbaum created a very famous chatbot called Eliza, which is a psychotherapist chatbot. And Eliza would actually chat with a human and would use keyword spotting and rules to come up with appropriate responses to the user's conversation. So the conversation might go something like, the user would say, "I'm feeling sad today," and Eliza would say, "Well, why are you feeling sad today?" So Eliza would sort of take the words that you gave to it and kind of throw them back to you in the form of a question, and it would spot certain keywords. So if you mentioned, say, your mother, it might ask you, "Tell me about your family." Or if it didn't have anything to say, it might just say, "I understand." So the technology behind Eliza was pretty rudimentary, but at the same time, it could actually hold a conversation, and it was the first serious attempt to create a chatbot. So from there, NLP technology actually advanced pretty quickly and became practical. So in the late 70s, there was a system called Lifer Ladder, which was used to query a database of ships using natural language. So if you were a business user and you don't feel like learning SQL to access a database, Lifer Ladder might have been useful to you because you could actually query the system and say, for example, what's the closest ship to Havana that has a doctor on board? And Lifer Ladder would take your natural language query, analyze it, turn it into SQL, and figure out what tables in the database to join together to bring you back results. So here very quickly we're saying a real-world application of NLP that can actually improve the user's experience. And from there, we entered in the 80s and 90s a real period of growth in this area, really highlighted by the rise of machine learning and statistical methods. So up until this point, a lot of NLP was based on rules and grammars and keywords. But in the 80s and 90s, you had a lot of machine learning algorithms developed that actually worked by analyzing statistics over a data set and making inferences that way. So there was kind of a shift between rule-based systems and statistical NLP at that point. In 1991, the Lovell Prize was created to award Turing Test winners. So the Turing Test all the way back in the 50s, people are still trying to pass this test today. And in fact, every year there's a competition sponsored by the Lovell Prize, and it's up to, I think, 100 grand. So if you can write a chatbot that can fool a panel of judges, there's some money in it for you. And people are actually still attempting this to this day.
That's great.
I think the best is, I think back in 2008 or 2009, there was a bot that fooled 3 out of the 12 judges. So it actually got a consolation prize, but no one's won the grand prize yet.
That's very cool.
And in 2006, NLP took a great leap forward when IBM's Watson question answering system actually won Jeopardy, defeating human opponents. That same year, Google Translate also launched and offered a number of languages that could be translated on the fly right through their website. So you can see the power of NLP systems really increasing in the 2000s with the rise of more computing power and also advancements in algorithms. Most recently, we've seen the development of personal digital assistants beginning in 2010 with Apple's Siri. Siri was actually a technology that Apple acquired from a company called SRI International that had some NLP technology in this area. And since then, it's really taken off. So one of the other things that we can ask is, why is it, if you look today, why is it that NLP is so popular? So nowadays, there are dozens of companies, small companies and large companies alike, that are developing NLP tools and NLP applications. And this is not only limited to natural language processing, this is actually across the whole field of artificial intelligence. So what is it about right now that makes NLP and AI so popular? And I think there's really 2 main reasons. The first is we have the rise of cheap and plentiful high-performance computing. So it used to be you need quite a bit of computing power if you were to build a really powerful AI system or NLP system. And nowadays that's available to everyone. So you don't have to have your own data center and your own rack of servers to do this sort of work. You can buy on-demand time from any of a number of cloud providers, and very cheaply get up and running and have a lot of computing power at your fingertips. The second big reason is the rise of open source software. So as we talk about the different components in natural language processing and what they do, you can actually find on the web open source projects for almost all of them. So we'll talk specifically about different areas of NLP and different algorithms, and almost all of them have multiple open source components that you can get off the shelf, which you can incorporate into commercial applications. So if you were building an NLP system 30 years ago, you had to build everything from scratch, and you had to have the PhDs on staff that really understood the algorithms and the math, as well as the computing power to execute this stuff. But nowadays, the barrier to entry for building an AI application or an NLP application is incredibly low. It's never been lower. And anyone, even companies that don't have as their business model software development, can put together an NLP or an AI system by composing these open source components and by getting computing time on the cloud. Okay, so let's actually start diving into some NLP concepts here. So I made the analogy earlier that NLP technology is like an iceberg. So what I mean by that is that there's a small part of this iceberg, a small part of NLP that's visible to people and to users. And those are the big ideas and the applications that we see out there. So machine translation, personal digital assistance, semantic search, those are all applications that use NLP under the hood. And the rest of this iceberg, there's a whole stack of technology that lies underneath those ideas, that those big ideas are built on. And that's some of what I want to get into today, so we can understand what are the building blocks and the methods inside an NLP application. So with this next layer down, you have natural language processing technology and also machine learning algorithms. So these are algorithms, a lot of them have been around for decades, but only now are they sort of componentized and available in open source and available with computing power so that they can be freely implemented. But NLP is built a lot on top of machine learning. And a layer below that, you have some boring stuff. How do you normalize text? How do you strip out the white space and get rid of punctuation and deal with different character sets and encodings? So there's a lot of boring housekeeping work as part of an NLP system, and that's part of the iceberg as well. And underlying all this is a lot of math. So NLP is a great field if you're into math. There's everything from trigonometry, linear algebra, calculus, lots of good stuff. And again, nowadays, you can actually obtain open source components that implement a lot of this math. So it's not necessary to understand it all at a deep level, but it's important to understand that the technology of NLP is built on top of very strong underpinnings in math and statistics. And finally, below all of that is software architecture. So nowadays, there are advances both in hardware in the cloud and also in software architectures to run distributed computing applications that NLP technology can be built on top of. So this is what I mean by the NLP iceberg. The visible stuff are the big ideas that you see in the applications, and underneath it are many layers of technology. So why is NLP so hard? Part of it is something I've already mentioned, and that text is really messy. You've got capitalization, punctuation, white space. People misspell things, misspell words. There are different input formats, document formats, character sets. So the sort of housekeeping part of NLP can be a challenge sometimes. And next is the aspect of language itself, which is ambiguous. So words sometimes have multiple meanings. So if I take the concept, the Mississippi Bank, am I talking about a financial institution, or am I talking about the bank of a river? So it turns out that noun phrase there is ambiguous. And humans resolve that instinctively when they see text because they understand the context that the Mississippi Bank might be used in. And if the words around that noun phrase are talking about rivers and geography, you might immediately come to the conclusion that we're talking about the bank of the Mississippi River. If the words surrounding that are more like financial terms, then you might immediately come to the conclusion that we're talking about a financial institution. But the fact remains that the language itself is ambiguous. This is actually a problem called word sense disambiguation, where you have a word like bank, it has multiple meanings. Humans resolve that through looking at the context of the words, and so computer algorithms would need to do the same thing, to look at the context of the word to decipher its meaning. There's other ambiguity in language in parsing as well. So the classic sentence is, I saw the man on the hill with the telescope. So am I looking through the telescope at the man, or does the man on the hill have the telescope? The sentence is ambiguous. And so again, this can sometimes be resolved with context, but the problem remains, which makes it difficult for computer programs, which is that the language is ambiguous. And on top of that, you have linguistic nuance in some text. So sarcasm, irony, humor, and that sort of thing. And last of all, if you're building an NLP system that's going to process any kind of social media input, you need to reach a whole new level of understanding eloquence there. So social media can be very challenging because of the tendency of people to make up words. So those are some of the things in the industry that makes NLP systems challenging to build. So from here, we talked about the building blocks in that NLP iceberg. I want to go over that in a little more detail and talk about some of the NLP tasks that are composed together to build a system that uses natural language processing. So at the top layer of this wall, you can see a few technologies that are really kind of the big ideas in the applications that we mentioned. So building a conversational agent, that might be an application. Or clustering documents, which is to take all the documents in a collection and sort them by topic. Or sentiment analysis. Sentiment analysis is analyzing text to gauge the emotional content of it. Is it saying something positive or negative? Those are kind of the big ideas and applications that are current. There are others like semantic search and summarization. And this is how those applications are built on top of lower level technologies. So to touch on each of them really briefly, word sense disambiguation is something we mentioned earlier. So that's where you have a word like bank, and you need to tell, are we talking about the financial institution or the side of a river? And it turns out that WSD is actually an open problem and a difficult problem in NLP. And it's solved by algorithms the same way that it's solved by humans, which is to look at the context, to look at the words surrounding the word bank, to figure out how they associate together. And are they more financial-ish words, or are they more river or geographical-ish words? So that's word sense disambiguation. And you often have to solve that problem on the way towards building one of those top systems in the first two layers. So this is one of the bricks that you have to solve for. Another one is called lemmatization or stemming. So this is something that we do all the time in search. So if you think of the word swim, the verb swim has different forms. There's the gerund form, ing, swimming. There's swims, swam. So that word, even though it really has the same meaning, can be modified by different inflections in a sentence. So if you were building a semantic search system and you wanted to search for, say, the word swimming or swim, you would want all those forms of that word to be covered under your results. So you don't want the fact that someone might have used that word in the past tense or in one particular inflection to prevent you from recalling a document that expresses that concept of swimming. So lemmatization or stemming is when we take a word and we reduce it to its root. So swimming and swam would all turn into swim. And again, this is one of the building blocks that seems simple, but you really need it to solve for it in order to implement some of these higher level systems. So next is sentence parsing. If you really want to understand the meaning of a sentence, you actually have to break it down and say, okay, what are the nouns, what are the verbs, what's the subject, what's the object? And so this goes back, if any of you have ever done sentence graphing in grammar school, computers, in order to understand natural language text, often have to do the same thing, to break a sentence down into its graph to really understand what it means. So that you can imagine how this might come in handy for doing something like sentiment analysis or building a conversational agent where you're really trying to understand some text. So next we have concept mapping, which is mapping multiple expressions of the same concept into a single expression. So for example, let's say the documents that I'm processing are medical documents, and I have references in there to a heart attack. Well, sometimes it might be expressed as a myocardial infarction, or it might be cardiac arrest, or a heart attack. So you can have multiple concepts, multiple expressions of the same concept that really mean the same thing. And so just like a human understands those to be the same, to build effective NLP applications, we need software to make that equivalence relationship. So we need software to be able to say, oh, heart attack, you mean myocardial infarction. Those are really the same thing. You can again see how this would be useful if you were building a search engine. If someone searches for heart attack, I would want documents to show up that mention myocardial infarction among the hits, because those are really the same concept. So concept mapping is taking different expressions, potentially multi-word phrases that mean the same thing, and mapping them to a common canonical form. Next we have part-of-speech tagging, which is tagging all of the words in the sentence with what's a noun, what's a verb, what's an adjective. This can again be handy for things like sentiment analysis and parsing. Named entity recognition is another brick in this wall. So named entity recognition is where you're trying to extract from a document all of the proper names. So what are the people, places, and things that are mentioned in a document? Proper names are often very significant to the topic of a document, and so it's very common that you want to identify in them who is mentioned and what are the proper names, company names, places, cities. Those are often very significant for the topic of a document. And so when you're just trying to build something that's, say, summarizing or clustering, you want to know what those proper names are because they're often very significant words in the document. So finally, we get to the very low level here, sort of the lowest brick in the wall, which is very simple stuff like tokenization. So tokenization is where you take a sentence and you break it up into words, and that's all. And you may think that this is an easy task, but tokenization is actually a non-trivial problem, especially when you consider different languages. So for example, Asian languages use logograms that are not like the Latin character sets that we use here. And what that means is different logograms or pictures, when they associate together, can change the meaning of the text. And so understanding where the word breaks are, or where the concept breaks are in a sentence can be difficult, depending on what language you're working in. And of course, even in English, there are some quirks. So for example, contractions. If I say the word can't, that's actually can not. So how would I tokenize that? Should that be 2 words or 1? And sometimes if you have text that's been, say, scanned from maybe something that's been typeset, you could have a word that's separated over line breaks by a hyphen. So your tokenizer, you might want to make your tokenizer smart enough to join words that are split across lines by a hyphen. So tokenization is actually an interesting problem in NLP, especially depending on what language you're working on, but it's sort of underpinning anything you need to build in this area. So generally the first thing you need to do to process text is to break it up into its words. And similar to tokenization is sentence detection, where you actually want to find what are the sentence boundaries. And this can sometimes be non-trivial as well, because you might have capitalized words in the middle of a sentence, or periods in the middle of a sentence if you have abbreviations. So sometimes it's not as easy as looking for a capital letter and punctuation. Sentence detection can be an interesting problem. And language detection as well. So there are algorithms to actually take a text and, having no idea what language it's in, actually try to decide what language is this text in. So those are kind of the low-level building blocks. And we can see as we go higher up the wall, we get to the really high-level concepts and big ideas at the top. So this is one of the things I want to impart in this talk, is that these big ideas and applications that we build in NLP, they're really composed of all these lower level NLP problems. And even these lower level NLP problems are open research areas in and of themselves. So there's a lot of content, there's a deep technology stack underlying natural language processing system. Okay, so that was a little bit abstract. From here, we're going to get into something more specific. So let's talk about one big idea that we can do in natural language processing, which is to measure the similarity of documents. So what could we do if we could quantitatively measure how similar two documents are? Well, for one thing, you could cluster them, right? So you could divide them up into bins by topic. You could also implement a very deep kind of semantic search where the input to your search is an entire document rather than, say, just a few words that you might have entered into Google. And if you knew which documents were interesting to someone and you had this metric of similarity, you could then build a recommendation engine. So you could find other documents that a user was interested in after they pointed out a few for you to start. And then you could do things like detecting plagiarism and copy-paste or even duplicates. So let's take a deeper look at this problem of document similarity, and we'll look at how we use some of those bricks in that Nlp Iceberg to build something like this. So how would you quantify how similar two documents are? The short answer is you measure the degree to which they are similar using similar words that are relevant to the document. So document similarity often hinges on a concept called TF-IDF, which stands for term frequency, inverse document frequency. So TF-IDF is a metric that measures how significant a single term is, or a word, to the topic of an entire document. So when you think about this, if I have a document and I have the word swim in it, how do I know how important that word swim is to the topic of the document? Well, the first thing I could do is I could count how many times it occurs. So the more time I see that word swim in the document, the higher I will surmise the importance of that word is. Similarly, if that word swim occurs in a lot of documents, I might actually lower my perception of its relevance. The reason for that is, let's say we have a collection of documents that our system operates on, and it's in the medical domain. So the word blood, let's take the word blood. How significant is the word blood to any particular document? Well, in the medical domain, you might actually have that word blood occurring in every single document. So it turns out that maybe blood isn't such an interesting word in that collection of documents. But if you were to say, okay, my documents are sports stories. If I have a collection of documents that are sports reporting, the word blood might be pretty significant because it probably doesn't occur in a lot of documents. And so what that means is that word is probably more significant to the documents that it does occur in. So TF-IDF is a metric that tries to capture this concept. The more times a word occurs in a document, the more significant the word is contributing to the document's topic. And the more documents that the word occurs in, the less significant it is, because if it's mentioned in all the documents, it might not be that important at all. So with this metric of TF-IDF, we can now build an algorithm that will tell us how similar two documents are. So a little bit of math and it'll be over quickly, I promise. The first thing we do if we're building a document similarity algorithm is let's tokenize the document. So step one is we're going to take our document, we'll pick out each sentence, and then for each sentence we'll divide it into words. So you can see on the right the result of that step. We'll take a sentence, the patient suffered a heart attack. Now step two, we need to apply a lot of this low-level NLP that we talked about from the iceberg. So the first thing we're going to do is certain words like V and A aren't really interesting to the topic of a document. We call those stop words because they're really kind of useless. They're articles. So we'll just drop them out. Next, we will take the words in the sentence and we'll stem them. So we'll actually remove prefixes and suffixes and try to get to a root of a word. So we'll take that word suffered and we'll turn it into suffered. And finally, we'll look for multiple word concepts in that sentence. And in this case, we find one, heart attack. So a heart attack, even though it's 2 words, is really a single unit of meaning. And we might have a database of these concepts that are relevant to the industry that we're working in. So if this was a corpus of medical documents, you might have this term myocardial infarction, and it might have several synonyms, heart attack or cardiac arrest. And so let's map them all to one common concept so they look the same. So we've turned that first sentence, dropped the useless words, the articles, took out the punctuation, lowercased everything, stemmed the words, looked up concepts, and now we have something much simpler. Patient suffer myocardial infarction. So that actually retains the meaning of the sentence pretty well. So step 3 is, let's take those terms that are left and calculate how important or relevant each term in that sentence is to the entire document as a whole. So we can build this little graph where the terms are across the x-axis and the height of each bar is what's the TF-IDF score? How important is that word to the document? So we have a word like patient, which might be pretty important, and myocardial infarction, which might be a really interesting concept, so that's probably pretty important. And there could be a bunch of other words in the document with varying TF-IDF. And notice that there'll be some words there that don't exist in our document at all. So maybe dog, the word dog didn't occur in our document, so it'll have a 0 for TF-IDF for that document. So in step 4, we can take all of those words and we'll build a vector, which is just a sequence of numbers from the term scores. So each position in the vector is a word, and the value at that position is the TF-IDF score of that word. So now we've taken an entire document and we've reduced it to a sequence of numbers. Now we can do some cool math on it. And this is often what NLP systems do, is to start by reducing text to mathematical concepts that we can now compute over. So finally, what we can do is in linear algebra, if we have 2 vectors, we can actually calculate the distance between them by taking their angle. So if we were to actually take these document vectors and take their angle, that angle can be looked at as how similar those 2 documents are. And so that's it. Now we've built a metric and a way of implementing document similarity so we can compare completely different documents and get a measure of how close together they are in topic. So hopefully this gives you an idea of how the different bricks in this Nlp Iceberg can come together and build something that's practical, which is a document similarity metric. So that ends the technology portion of this talk. From here, I'm going to hand it over to Pete Fitzsimmons, our CEO, and he's going to go into the practical applications of this technology.
Great. Thanks, Craig, and good afternoon, everybody, and thanks so much for the blocking and tackling around how NLP comes together. There are some important concepts there, and what we're going to do in the second half of the discussion today is pivot off of that concept of document similarity and look at how can we now implement these tools in a way that really has practical application in a whole host of different sort of business scenarios. And the key takeaways we want to have in the second half of the talk today is around the fact that these technologies and capabilities are affordable. They can be very effective in achieving the goals and objectives that are outlined in the implementation, and that these technologies are accessible for all sizes of organizations. So what we're going to talk through this afternoon are 4 different use cases in how we can apply NLP machine learning and this concept of quantitatively scoring content to do document similarity. And we're going to illustrate how NLP technology and machine learning can improve efficiency and enhance insight into content within organizations, within a marketplace. We're going to outline how NLP can enhance the user experience and for how folks are interacting with content, and in particular in a highly personalized or customized interaction. We're going to talk about how simply increasing the amount of automation in an organization can fundamentally support consistent and sustainable quality of performance, and how it can also support the growth of an organization. And then finally, we're going to illustrate how implementing NLP, machine learning, provides the opportunity to innovate and really truly unlock the hidden value of digital assets buried in an enterprise and an organization's content across the entire spectrum. So on the slide here, we've got 4 industry examples that we wanted to dive into a little bit. We've got a series of bullet points here that speak to, at a high level, how we have seen NLP in action in each of those industry verticals, whether it's in relation to personalization, an enriched user experience, and the opportunity to provide user-level defined classification of content, and really looking at user profiles and this area of narrowcasting, and using document similarity to enhance classification of content. So we're going to look at that in the context of the media and information services vertical. It really goes a lot broader than that. It speaks to entertainment. It speaks to all types of content, whether it's in the education market or whether we're talking about teenage romance novels. NLP is being used today to achieve all of these fundamental areas. We're also going to dive into the policy and legislative content market. NLP is naturally well positioned to help solve challenges in those marketplaces where there is tremendous amounts of content, so voluminous expressions of content in the legislative and compliance and regulatory arenas, makes NLP a great tool set and technology base to be able to solve some really significant challenges for organizations in that segment. And of course, policy and legislation and regulation have a tendency to be complex. And so NLP can be a great tool to reveal some hidden insights that can be, draw the curtains back on some of that complexity. We want to talk a little bit about the enterprise search market and some of the history there, and unfortunately some of the failed promises of prior implementations around improving access to enterprise content across the organization. I'm going to highlight how natural language processing, particularly given some of the factors that Craig had mentioned before around the accessibility to open source tools, as well as the cloud environment that we have today, that's really significantly impacted and increased the access to content. I'm going to look at how that's fundamentally changing just the enterprise search marketplace. And then we want to close out with some illustrations in the legal field. Natural language processing has been prominent in legal services and delivery and analysis for quite some time, particularly in this area of litigation support and e-discovery, where attorneys have been challenged for decades, if not since day one, in understanding what is present in a large body of content, reams and reams of documents. I'm going to talk a little bit about how NLP is now extending beyond some of those initial implementations. So our first area that we wanted to dive into is how is NLP being used today in the media, information and entertainment market? And this concept of document similarity is really a tremendous enabler in this news, media and entertainment marketplace. The Netflix problem, which is essentially the challenge of understanding who's sitting behind the screen. Who is that person that's interacting with my content, and how can I determine what they're really interested in? And how can I get to them the pieces of content, whether it's the latest version or the latest episode of Stranger Things or the latest movie set that may be coming to market? How can I understand what they're truly interested in? And how can I get the information and content to them when they need it and how they need it? And this Netflix problem extends across anybody dealing with content. And so the Washington Post has invested into completely re-engineering their value chain around how they produce content, how they write news articles, how their newsroom functions, how they then position content and understand what their readers are truly interested in. And they've actually taken their entire publishing platform, and they've now exposed that out to the news and media market as an independent piece of technology. And the fundamental core of that re-engineered technology platform is natural language processing, because it's so critically important if you're in the news media and entertainment markets to understand, what are your readers really interested in? What are the areas and the topics that are highly relevant and important to them? And how can we write and produce more of that content that really speaks to their interests and their likes more specifically? So document similarity enables us to do a whole bunch of things really quickly and easily in this regard. We can classify content because the natural language processing using document similarity can tag and classify content at the most deep and nuanced level. So once we've classified content, we're able to then match content to a particular user's interest that they could express to us. Initially, they would do that through telling us, what do you like and what do you dislike? But then ultimately, as they're interacting with that content, they're telling us even more detail around what those likes and dislikes are as they go forward. So entertainment organizations like CBS Sports, ESPN, the Bleacher Report, they've been using natural language processing to not only classify information and content about what's going on in the NFL, the NBA, Major League Baseball. They're classifying stories as they're coming in from a huge number of different sources, and they're able to then match those stories once they're classified to their subscribers and to their readers. So they're able to dish up to them and make them aware of news articles and features that are highly relevant and important to them. This whole market extends even further than just to news and media, implementing natural language processing for anybody that's dealing with content and is looking at the interests of their stakeholders needs to be thinking about, how can NLP help me do a better job in a shorter period of time with less resources. And so if you're in the information services market, if you're in the association market where you're looking to advocate around certain interests and you're wanting to engage with your grassroots campaigners and to your individual members and get them motivated about things that are important to your organization, NLP can be a fantastic technology that enables you to be able to bring to them pieces of content information that are really highly relevant and important. So NLP in news, media, information publishing, it's not just the realm of the Jeff Bezos and the Netflix of the world. Small non-profit organization, member organization associations are implementing NLP today to classify their content and be able to match it to their members' interests. The next area we wanted to talk to is around the policy and legislative market. And so there are tremendous amounts of content that are available in that marketplace. We're seeing policy continue to fragment, where it's moving from the federal government down to the state government and then even further down to the municipal level, where local governments are implementing regulations and legislation and policy at that very much that local level. And so for those stakeholders that are interested in understanding what's going on in federal legislation, state and local legislation, the amount of content that they have to deal with and the amount of complexity that they're having to work with is just exponentially getting larger and larger and larger. And so the challenge in this space is only increasing in its size. And this is where, again, NLP can be a tremendous tool and a technology that enables you to get greater amount of insight into what's going on. The other challenge in this market is that traditional providers of tools and technology are the big content aggregators, the Bloombergs of the world, LexisNexis, etc. Their technology platforms are built around simple search criteria using some of those capabilities that Craig had mentioned at the start around keyword searching. And the challenge there is that those tools are not intuitive, they're historically hard to use, and they're just not truly effective. It's like Googling for the latest and greatest around what's going on with opioid legislation and getting 10 million returns coming back at you. It's just not practical or sustainable at a meaningful level. So natural language processing can help regulators, stakeholders, analysts in the government affairs and policy market to really target content that's specifically important to them, irrespective of how nuanced or niche their particular issue might be. And NLP can enable you to look at those issues across all sorts of jurisdictional levels, across thousands and thousands and thousands of documents, and bring back just those particular pieces of content that are specifically relevant and important to the individual user. So we're seeing these types of technologies getting developed in the compliance world. We're seeing it applied to regulation and compliance and policy by a whole range of different technology providers and all sorts of companies and organizations that are participating in that particular market. The next area we wanted to touch on is in the area of enterprise search. And historically, the way that companies and organizations, there've been tremendous promises made by the large technology providers like Microsoft and others where implement this knowledge management strategy, aggregate all of your content into SharePoint, and you'll be able to access any of the information across your entire organization at any time, and when you want it and how you want it. And unfortunately, the promises that were coming out of these corporate wikis and knowledge bases and the SharePoint implementations, not only were they really, really expensive and difficult to implement, unfortunately, the promises of being able to access all of your information at any time from any place also fell well short of expectations. Today, in the age of AI within the enterprise, the promises of natural language processing and machine learning are that you can now truly access every piece of content across your organization and your enterprise, and it doesn't have to be in a single repository. The historical customer management systems, they didn't implement a framework that was sustainable, that was easily maintained, and had a natural expression of how your employees or your stakeholders really thought about how to organize content. Natural language processing enables any employee or user within an organization to bring how they think about content to that implementation, to that framework. So natural language processing now allows seamless access across all content repositories, and for each individual employee to be able to express what their definition or classification is of corporate content, so they can access it when they want, how they want. And they can also now use semantic search to inquire back against those huge content repositories to access the information that they're interested in. So instead of having to create 300 or so nested Boolean statements so that they're able to think of all the possible combinations of different keywords that might be out there to be able to pull back the information that they're looking for, they can use semantic search, which is just a natural expression of what they're interested in. And then that bag of words will be able to go out and capture the concepts that are important to them in the enterprise search repository. And our final area that we wanted to touch on is in the realm of legal services and analytics. And it's as I mentioned, it's broadened slowly, but it's certainly gaining momentum in the use of natural language processing in the legal services market. And we're not just talking here around LegalZoom, where folks are able to go to a central location and be able to complete a quick and easy form using a rules-based approach that will then produce a set of incorporation documents for them. Natural language processing is enabling the complete re-engineering of how attorneys and corporate counsel and state and legal services providers think about how to review contracts. How do I complete contracts? And the entire contract management process is being completely overhauled, where natural language processing is able to review contracts, triage contracts that are coming in from vendors, identify non-standard language that might be captured in a contract, so that can be then presented up to an attorney to then really use their experience as a subject matter expert to scrutinize and to interrogate what that non-standard language might represent. Other areas, there's a group out on the West Coast of attorneys that are using natural language processing to review loan agreements and settlement contracts in commercial real estate. They're actually they're planning to use artificial intelligence to then also complete those contracts and then implement the finished contracts with blockchain to completely disrupt and bring innovation into the commercial real estate and lending markets. We're seeing NLP being used to interrogate compliance review to ensure consistent quality control in the review of areas like anti-money laundering and financial services or fraud detection. And then finally, natural language processing has enabled the whole research effort within law firms to be completely overhauled and re-engineered. The traditional legal law library, where a law librarian would be charged with doing all of the research for attorneys within a legal services firm or within a law firm, that's no longer required, as natural language processing embedded with a content management repository is able to enable attorneys to do all of their fundamental research themselves. So we see the future legal services getting very much disrupted using natural language processing and machine learning, and ultimately natural language generation, which is another iteration in the artificial intelligence umbrella, to really completely change how legal tasks are being performed and how the legal services industry is going to change completely. So finally, what would we like you to think about here today in terms of takeaways? We hope you've learned some basics around what the building blocks are around natural language processing from a technology standpoint, and what the blocking and tackling represents around the actual technology itself. We've highlighted some industry use cases where we're seeing NLP being implemented today and being used effectively by organizations of all shapes and sizes to solve fundamental business challenges that they're having in very practical and pragmatic ways. And then we hope you'll be able to take those use cases and your understanding of what NLP sort of represents and look for opportunities within your business to be able to apply NLP in a very practical fashion and then start experimenting or start implementing. So to look for those opportunities where you can improve efficiency, increase insight, enhance your user experience either for your employees or for your stakeholders, your customers, and for your members. Look at ways in which you can increase personalization and ultimately provide automation and opportunities of innovation so that you can unlock the true hidden value of all of your content assets across the full spectrum of the enterprise. And it can be text, it can be video, it can be audio. NLP at the end of the day can be applied against all of those content assets. So thanks for your time today. I think we're going to take a couple of questions.
Yeah, it looks like we have a couple of questions from our audience. Are policymakers within government investing in NLP tools to understand what information and services are relevant to constituents, and does it have implications in the development of public policy? Any thoughts around that?
That's a great question. And policymakers today are certainly becoming much more aware of how NLP tools can and possibly should be applied to information and to content to understand how they're relevant to constituents. A great example of NLP being applied is the recent debates around net neutrality. And government has historically used a comment and response process to gather feedback from the public around proposed changes either to policy or legislation or to regulation. And in the net neutrality debate, the FCC exposed out over a portal the opportunity for the public to come and submit comments around what the public thought about the changes that the administration was introducing around net neutrality. And typically, the various government agencies, maybe they'll receive hundreds of thousands of comments from across the nation. Possibly a couple of million would have been on the high side. On net neutrality, the FCC received approximately 20+ million comments from the public. It exceeded all expectations by an order of at least 10 to 15x. Later, very shortly after the comment period was closed, though, a number of NLP companies and researchers applied natural language processing, in this case not to do content classification, but to identify patterns in the content, to expose potential examples of where comments were being artificially manufactured. And in fact, what happened in this regard, it was determined by a number of different researchers and corporations using NLP that of the 22 million, approximately 19+ million of the comments were formulated by bots using NLP and natural language generation to produce them. So it has significant implications, we think, in terms of how public policy is developed, the ability to use content and document classification to score new policy documents and to score new regulation documents, to be able to assess, is there a lot of duplication or overlap in regard to new pieces of legislative works and new regulations that could be overextending beyond what the intended scope of those pieces of legislation and policy might represent. So we feel it has huge implications for the public markets and the development of public policy.
Excellent. So we only have a couple minutes left, and I do want to leave you at least a minute to talk about Contexture and how you help your clients. If you could just briefly touch on, we have another question around making the justification for investment in Nlp, and what are some of the barriers that you see that senior management might present. Do you have any thoughts around that?
Yeah, I think in our experience, the justification for investment in NLP is easy to present. The key parameters there are in identifying what the objectives are for the implementation. So having a very clear business case around the problem to be solved. So are we trying to address inefficiencies in our organization around how we classify content? So an understanding of what does it cost us today to classify content, and then how can an investment in NLP help us re-engineer that process to produce great content efficiencies? A different use case would be where we're trying to better target our content to users. So what are the expectations that we have in either reducing the churn of subscribers or increasing the number of subscribers that we may be able to attract into our platform? So having clear objectives that are very measurable and understanding how we're going to demonstrate success for an NLP project is really important. And that's a fundamental building block around the justification for an investment in NLP. So the typical points of resistance coming from decision makers are around the issues of affordability. Are they truly effective? And can this be a practical implementation of what is perceived to be a very complex piece of technology? The other typical point of resistance from decision makers is an expectation that NLP is magic. And so managing senior decision makers' expectations around what can NLP do and what is it really good at, and the demystification of NLP and what areas of NLP is it not really well suited to address. I think they're the key things. Craig, anything from your side on those points that you'd like to add?
Yeah, I think thinking about NLP investments in the traditional sense and having to come up with an ROI makes sense for any kind of technology investment. And so I think it can sometimes be useful to look at the benefits of NLP in terms of, well, how can I repurpose staff from maybe mundane activities like just reading documents and taking notes or doing research up to higher level analytical functions, and what effect could that have and what benefit on the business could we have if we can automate some of that? So I definitely think that an ROI view towards it could be useful. Excellent.
So in the last minute we have here, and to close out our session today, who does Contexture help and how do you help them?
Great. First, and thanks, Jessica, for inviting us here today for the webinar. We really appreciate the partnership with CATSI Consulting and you're inviting us along to talk about NLP. Contexture is helping customers across all of the industry verticals that we touched on today, and we're helping them with fundamental challenges around understanding the content that they have available. So as Craig mentioned, looking at what resources are currently being deployed to understand content and to work with the content that they currently have, and then how can NLP be an effective solution in helping them to improve the efficiency and the effectiveness of understanding content. Our first implementation is a product that is called BillWatch that's targeted towards folks in the legislative and policy arena, and we're using our NLP technology and machine learning engines to be able to help customers there to understand the huge cross-section of legislation that's available here in the United States. 250,000 separate pieces of content, independent bills that all the states and the federal government are pushing out to the marketplace and helping those customers to understand, of those 250,000 bills, what are the key 100 bills that are going to impact their members or impact their industry or impact their corporation with critical investment decisions that they're trying to make. So Contexture helping customers with increasing their efficiency, enhancing their insight, and increasing their revenues, all fundamental things that impact every enterprise and organization across any industry vertical.
Excellent. Well, thank you, gentlemen. Really appreciate today. Learned a lot, and thank you to our audience. For the audience, I really encourage you to visit their website, reach out to these guys and learn more about what they have going on. Thank you, and have a great day.
Thanks, everybody. Thanks, Jess.